Hello, everybody. How are you doing today? That's the last session of your day. Happy it was a meaningful day, first day of reInvent. Happy Hanukkah. Hope everyone is feeling well, and finally, this pandemic is not going anywhere, but hope you're enjoying traveling. So my name is Amiram. I'm the founder and CEO of a company called Spot.io. And the company was acquired by NetApp about 18 months ago. And right now I lead the division called Spot by NetApp. And we're going to talk today about cloud ops and best practices of how to optimize costs in the cloud. So it's going to be a lot of information. I'm just saying it right now. But just so feel free. I want to make it interactive. So if you have questions, so feel free to raise your hand, and I can pause, and we can go through some questions. But before that, just like Spot.io is a startup that got acquired. Like every startup, it was a Cinderella story. The story basically is that about 7 years ago, I was a student for computer science. And in my last 2 semesters, I was running a research about optimizing cost in the cloud. And that research ended up being focused on AWS EC2 Spot instances. Anybody not familiar with EC2 Spot instances? So it's AWS compute, like spare capacity. And I was researching on more clever ways to use Spot instances for production workloads. And I ended up not graduating, but ended up starting a company and selling it. So I hope that's a good outcome. So we're going to talk today about the evolution of Spot, started from this academic research of running Spot instances in production into today, which is a very broad portfolio of products that helping customers to optimize costs in the cloud. So I think the foundation of everything that we build at Spot is happening on multiple vectors that we see in the cloud. First, we see that something that is true now and will be true, I believe, in 10 years from now, is cloud is getting more complicated over time. It's not getting any simpler. There is more permutations of compute. There is more different type of services. It's always the pace of innovation of AWS as a cloud provider is very rapid, so just keep up with all of that every year. It's pretty hard. The second is what I believe is true today and will be true in 10 years from now is cloud is getting more expensive. So we're deploying more workloads, we're spending more money, we're using more, and hopefully that's helping our business, but we're just using more of cloud and we're paying more. And I think in the junction of that, we see that there is shortage of people that really know what they're doing. It's really hard, let alone when you work in a multiple clouds environment and when you work in a cloud-native environments and containers and serverless. So there's a lot of moving parts. And as a DevOps, that's what I was doing as a student. I was working as a DevOps. I had limited time to deal with everything from securing, building CI/CD pipelines, and optimizing cost. You always need to choose one thing you're going to do today. And cost was always the last thing you want to do. So, and that's how we think about building products at Spot. I don't want to sell you too much on us, but really explain what we build and why we build it. So when we talk about cloud ops, we really think about 3 main pillars. Recently, we've added 4th pillar. But cloud ops to us, when we speak with customers who are managing cloud, we see 3 main categories that they really care about. The first category is DevOps, is how you provision your infrastructure, how you deploy your CI/CD stuff, how you monitor your applications, basically SREs, DevOps. The second thing is SecOps. Is as you deploy in the cloud, we understand that we deploy, we have multiple moving pieces, and we need to make sure we have no misconfigurations, that everything is falling to the right place. So security operations is something that is really part of today's modern cloud ops practices. And then the third pillar is FinOps. There is a huge change in IT We used to buy servers with finance, and we know exactly how much it cost us. But right now in cloud, just a developer comes into the AWS account, spin up resources, somebody's paying for this. So FinOps is the people in the company that are responsible so that you will pay only for what you use and only for what you need. And that actually created a big shift in how we think about payments to cloud and how we think about usage in cloud. And then the fourth pillar that we recently added is PCOps, is basically also getting not only infrastructure in the cloud to run applications, but also run desktops. Especially with remote work, we see more and more companies just living like regular laptops and basically managing everything through desktop as a service in the cloud. So the evolution of Spot over time across these FinOps, DevOps, SecOps was to build products in each category that helps customer to answer those challenges that we said that are true today is going to be true for in 10 years from now, of complexity and cost reduction. And if you think about it, there are two categories in cost reduction. So we have cost management, and we have cost optimization. And cost management is basically how you view your bill of AWS, who's using what, and putting the right tags and stuff. This is cost management. But cost optimization is basically how do I apply automation to optimize things autonomously. So I don't actually go and tell people what to do. Is basically have something on autopilot that does it. So now we're going to go through the product portfolio and going to give every product about like a few minutes of sunlight, and happy to pause and take some questions so we can go over this product portfolio and explain how we help customers to optimize cost. Before we get there even, I'll tell you that today Spot is being used by over 3,000 customers, from the largest customers in the world and customers we have public reference with, from Ticketmaster and Sony and Samsung, but also big financial services and top Fortune 5 customers, and I believe over 30% of Fortune 100 companies in the world are using Spot. We're managing today roughly a little bit over 1 million EC2 instances at any given time on behalf of our customers. And this number is increasing in about 7 to 12% month over month. So that's pretty large scale, and we're talking about a lot of money saved for our customers, and we want to walk through the type of products that we are actually providing to customers. So let's start with the DevOps category. So in the DevOps category, we have a product called Elastic Group that works for virtual machines, which is traditional workloads that are EC2 based, different type of use cases from Jenkins workers and applications behind load balancers through EMR and Beanstalk and OpsWorks. So everything that you can think of that you do with EC2 that is something that is elastic and scalable, this is probably something that Elastic Group can cover you. And we'll go through Elastic Group in a second. And then we have another category called containers, that we have products that help to manage containers and automate containers autonomously, and we'll touch about it as well. So Elastic Group. Elastic Group, it's anybody here using auto-scaling groups of AWS? So Elastic Group, I love to call it auto-scaling groups on steroids. It's basically built from the same fundamentals and principles of having a template of how to provision collections of instances and then scaling it with scaling policies. But what's really different about Elastic Group, that it's using machine learning, something that from my academic research, and we've built it for the last 6 years, it uses machine learning algorithm to basically predict when Spot instances are about to be interrupted and replace it in instances before that happens. It also honors if you have reserve capacity, so it will use it first and then use Spot. And then if Spot instances are not available, it will fall back to on-demand, and we move back to Spot instances. So it's a very sophisticated engine behind the scenes that powers Elastic Group to provide the most powerful cost optimization at scale without you doing anything. It's just defining the template, defining the scaling policies, and then Elastic Group is on autopilot. And the nice thing that Elastic Group is providing SLA to running Spot instances because it can predict before they go away, and it can fall back to on-demand. They're so nice over there putting music for us. So of course, if there are questions, feel free to raise your hand. So what makes Elastic Group powerful behind the scenes? What powers Elastic Group? So there are three things. So what I said is actually provisioning all the pricing models that AWS has to offer. So provisioning Spot instances, on-demand instances, reserve capacity, but also can honor any savings plans or any existing reserve capacity that you have. So it's very aware of pricing models. The second thing, it has predictive scaling. What is predictive scaling? It's basically understanding over time how your capacity trend is looking like. For example, every 10 a.m., we're doing scaling up activity. Every 9 a.m., there is scale down activity. So Elastic Group will learn that and will make your cluster smoother over time. So that's one. And the third, Elastic Group has a unique capability called intelligent traffic routing. And what is intelligent traffic flow and intelligent traffic routing is if you really want to leverage Spot instances to its fullest, you basically need to use multiple instance types. So that means you need to, because the way that Spot capacity works at Amazon is think about it as spare capacity. Amazon have a lot of hardware. They have hardware of C5, they have hardware of C4, hardware of C3 and M4 and R3 and X instances. In every instance, they have different capacity and different demand. So sometimes the reason or the fact that there are no capacity from C4 large instances doesn't mean that there are no capacity from C4 2x large instances. So basically, our algorithm will always try to find the right combination of instances so they won't disappear together so customers can get SLA. But that means we need to use multiple type of instances. Now, the problem with using multiple type of instances that's called heterogeneous capacity, the problem of this that your application will start on an instance of extra large and on an instance of medium. It's not going to work the same. And if you have a load balancer in front of it and you have 100 requests, the load balancer will send 50 requests to the extra large server and 50 requests in not a proportion way to the medium server. And that's not in alignment with your application and the performance you want to get. So what Elastic Group does, it basically understands that it provisions different type of capacity and actually puts different weight on the load balancer target groups. So if you have an extra large and a medium, it will send 70% of the capacity to the extra large server and 30% of the capacity to the medium. So then you can optimally get your performance and you get the perfect SLA and cost savings with that cluster. So pretty unique product. Elastic Group is being used again, by the largest companies in the world. A lot of, one of the industries that really like Elastic Group is from the media and tech advertising. We have a lot of real-time bidding applications working on Elastic Group. And that was breaking, I would say, even like a taboo that how can Spot instances work for real-time applications? Spot instances used to work only for scientific computing and some batch processing, but no, Elastic Group is serving today real-time, user-facing applications. There's cool UI for Elastic Group, and like what you see here, that's a really nice screenshot when you provision an Elastic Group cluster and you're choosing your machines. So it basically gives you a heat map telling you, hey, these are all the capacity pools of AWS. And the red like means no capacity right now. Green means like I can basically get lots of capacity right now. So Elastic Group is always monitoring it behind the scenes, and this is what powering the machine learning algorithm that behind the scenes. Just to summarize, if you have one of these workloads, you should probably tell your team to check out Elastic Group. Could be a perfect use case for them. Could be anywhere, anything that uses ELB, anything auto-scaling group. Jenkins is a really good process. Also, big data workloads from Hadoop, Spark, EMR, and anything that running on auto-scaling groups, basically. Also, moving forward to containers. Anybody here not using containers? All right. So containers are the future, I would say. And what makes containers so, I would say, so amazing is that the fact that you can just package everything into a deployable unit. And then when you have a deployable unit, you need something that can help you to scale that deployable unit and manage it at scale, which is Kubernetes. Google did a really, really good job in open sourcing what they do for their data centers. And today, we know that Kubernetes is the #1 platform for running containerized applications. When you run Kubernetes, the problem is that you have a lot of infrastructure management overhead. If you look at what's the process of running Kubernetes, you need to build a container, you need to define how to deploy it, you need to have the right infrastructure set up, you need to provision it, configure it. Do I need a medium servers, extra large servers? Do I need a GPU servers? Do I need high memory servers or high CPU? What's the network throughput I need per server? You really need to think very deeply about the infrastructure that you provision. And then you provision it, you need to run it, you need to manage it, you need to patch it, you need to configure it, you need to scale it. Lots of work. And we know there are teams who have like SREs that only what they do is just running Kubernetes, and this is what, like, it's a full-time job. So again, going back to the same two things that are true today and going to be true in 10 years, like Kubernetes is complicated, it's getting costly over time. So we launched a product about 3 years ago called Ocean. That Ocean tries to simplify a lot of these provisioning and management and auto-scaling and patching of Kubernetes and provide fully managed compute. But this fully managed compute is basically built on the same principles that I just showed you before of Elastic Group, that is aware of pricing, can launch spot instances, reserved instances, on-demand instances, but also aware of, I would call it the big Tetris game that's happening between the containers and the compute instances. Because if you think about it, containers, the pods, the deployable units are decoupled from the compute instances. You can deploy a pod with one CPU and place it on a compute instance that has 32 CPUs. So there is a lot of place of bean packing, we call it Tetris scaling, that you need to do really well. So Ocean has an algorithm with a patent, by the way, that basically it's a big mathematical equation at the end of the day. Like we have a collection of pods and a variety of compute types from the cloud provider. And what's the best permutation and what's the best equation to make it in the most optimal way? But not only the most optimal way, but also in the most cost-effective way, the most performant way. So Ocean does exactly this. It uses machine learning and uses algorithms behind the scenes to match and place pods on the right instances so it will cost the least and will also be in the most performant possible. The next thing that it does is that once you have your containers running, one of the problems, in my opinion, when I started to use Kubernetes, so you define a pod. But when you define a pod, you really never know what this pod needs in terms of memory and gig of RAM and CPU. So you basically deploy a pod and then, okay, how much resources do I need for that pod? Let's put 4 and 10 gig. Why? I don't know. So what Ocean does is pretty unique here. That tells you, don't even think about that. Just deploy the pod with whatever you guess, or you don't even put anything there. And then Ocean will profile that container, and it will right-size it over time. So we're taking here with Ocean, it's called the Netflix approach, which Netflix, what they do is they let their engineers deploy on the most expensive server because they don't want the engineer to work slow or to get bad performance. And then over time, they have processes that are downscaling the server exactly to match what the application needs. And that's what we do in Ocean. We let you define what you need, and then over time, just reducing and trimming, or sometimes expanding what the container needs. And we had a very interesting use case with VMware in reInvent 2 years ago that we did a session together, that VMware is using Kubernetes at a large scale. And we told them about Ocean. We have a long relationship with VMware. And what we were able to figure out, they just moved their cluster to Ocean. And just by using the bean packing, they were able to have 30% less capacity than they had before, just because of this bean packing. And then over time, they were able to save another 20% just by this right sizing, let alone that they were able to use spot instances and reserved instances in a very sophisticated way. We're talking here about huge savings. And I'll tell you, like, that's the way to run Kubernetes today. That's the way to run containers today in the most optimal, the most efficient way, and that's Ocean. Happy to answer anything. So Ocean is not stopping here, and Ocean is continue to evolve and continue to expand. And when we talk about Kubernetes, most of the time, we talk about microservices. We talk about web applications. We talk about small containers that are running some apps. But over time, what's actually being deployed on Kubernetes is also platforms. Platforms like Kafka, platforms like Elasticsearch, and platforms like also Apache Spark, which is one of the most increasingly growing platforms that is being run on Kubernetes. Why Apache Spark on Kubernetes, by the way? Because Apache Spark is built on a foundation that there is a scheduler that helps Apache Spark place jobs on compute instances. This used to be a very old scheduler that was called Yarn. And Yarn is something that's built for on-prem environments. It's not really built for the cloud. So Spark on Kubernetes is basically replacing Yarn with Kubernetes as the scheduler. And we all know that Kubernetes, if you want to pick the winning horse to schedule your pods, it's Kubernetes. And by running Spark in Kubernetes, you can get much better auto-scaling capabilities and density in your cluster. So we've decided to work on placing Spark on Kubernetes in the Ocean way. So you can run it on the right compute instances in terms of pricing. You can right-size the pods based on the machine types that you can acquire from the cloud, but also resize Spark jobs, because Spark jobs behaving exactly like pods. When you deploy a Spark job, you need to define the resources they consume. So here, you don't need to think about the resources that they will consume, because it will automatically learn them, and then your Spark jobs will become absolutely optimal over time with Ocean for Apache Spark. Here's a more technical implementation of how it works. You can quickly take a photo if you want, but I don't want to get too much into the details. I know it's a lot of information at, what the time now? It's way past what we want to observe more and more technical details. There is a version for Ocean. Also, if you want to take Ocean just for a spin and just understand what it can do for you. So we have a light version of Ocean called Ocean Insights, which is you just can deploy Ocean in a read-only mode in your Kubernetes cluster, and it will discover everything in your cluster and will tell you how your cluster can be optimized. And this is a very light installation. It takes about a few minutes, and then you get some really cool charts and visibility into what you can do better in the cluster. So you're more than welcome to take a look. Now, Ocean keeps expanding. This is a product that we're investing a lot, and we're seeing tremendous amount of interest from customers. And one of the problems that we see in Kubernetes, and Kubernetes is built basically to deploy lots of applications. And these applications, not like we used to release versions in the past, release a version every 2 weeks, every month, every week. We're releasing versions today, every day, every hour, multiple times. And when we release a version, so we're doing a new deployment because we want that new version to be in production. And Kubernetes is well known by doing rollouts. So you create a deployment, and then you are applying a new deployment, so you create a new container image, and then Kubernetes is doing a rolling update. So it replaces the old pods with the old version with new pod and new version. Kubernetes does it pretty well. The problem is that when you do it very often, so sometimes you're really losing track of the visibility of the process, and also losing track if the application is actually responding well to what's going on. You can find it out after like people are yelling at you, or you see in your Datadog metrics later that something is breaking, or that something is not working, or you get exceptions from customers. But Ocean Continuous Delivery is basically intercepting at the stage of when you build your version, you test it, you prepare to deploy it. Usually with Kubernetes, it happens on the GitOps level. You create a new YAML, then you apply it. Whenever you apply it, Kubernetes starts to roll it out. This is where Ocean Continuous Delivery gets into the picture. You're starting to apply, then Ocean Continuous Delivery, Ocean CD, is intercepting there, understanding there is a new version, and then for every deployment, the customer defines a metric that you would like to monitor. It can be the latency of this application. It can be the amount of HTTP 500 requests. It can be the number of queries per second. And then it will verify that it's not deviating from the normal or going above or below a threshold that you define. And then it helps customers to deploy fast with confidence, because if something is not happening as expected or as you wish, there is an automatic rollback that can happen with Ocean CD. So that means that you can use Kubernetes, scale very fast, deploy a lot, and still do it safely with a lot of confidence. Now switching gears to the FinOps category. And I would say this is a very exciting category for us, because I think the cost problem in the cloud is just becoming more and more and more complicated, and we're seeing organizations bleeding sometimes, and we're seeing that it's very hard to come and solve this like really big problem of understanding how to save and how to go about cost in the cloud. So first of all, I would say that it's pretty exciting times. My company was acquired about 18 months ago. Since then, I was lucky enough, together with NetApp, who acquired Spot, to acquire 4 companies in the last 18 months. The last one that we've acquired is CloudCheckr. We announced it I think we closed the acquisition on November 7th. And basically, that allows us to expand from the category of cost optimization, of being actively doing optimization through all this automation that I was talking about, to also provide it in cost management, help people understand, see, discover what they do, and then act. So CloudCheckr is part of our product portfolio right now, and we're working to integrate it very, very tightly into our products. So we will continue to release updates about it, but I would say, warm welcome to the company. Other than CloudCheckr, we have a very, interesting and unique product in our product portfolio called Eco. And Eco, I was very excited talking about Ocean, but I can tell you that Eco, that's the fastest growing product that we've ever had. And that's the product that we see the most amount of demand ever. And I think you'll understand why in the next 60 seconds. So when you think about cloud, I would say there are a few things to go about. There is, do I need to commit to the cloud to get discounts? And if I don't need to commit to get discounts, how do I get discounts? So we're basically bifurcating the cloud to what can run on Spot instances, because this is like no commitment instances, and what cannot run on Spot instances. And what cannot run on instances is basically it's either on demand or reserved capacity. And on demand is expensive. And reserved capacity, it's complicated, because one may think that reserved capacity, this is something that you buy once a year, and you just say, I need 100 machines, 1,000 machines, I buy it, I get the discount from AWS, see you next year, we're going to renew it or buy more like 1,500 or 2,000 or 500, and then that's it. But wrong. Reserve capacity is something that you buy every week, sometimes something that you buy every day. Because reserve capacity, this is something that is changing over time, usage changes, applications are consuming more or less, and you need to respond to that in real time, so you get the real benefit of actually reducing cost. So what Eco does is very unique. Eco is basically learning the usage of your account of whatever cannot run on Spot instances. By the way, if you want to run even Spot instances workloads and not run it on Spot, but run it on Reserve, that's also possible. But what it does, it basically creates a portfolio of strategies to purchase commitment. What do I mean? So if we want to commit to AWS, how many ways do we have to do it? We have Reserve instances, we have 1 year, 3 year, we have convertible RI, and we have standard RI. And then we have savings plans. We have compute savings plans, and we have just general savings plans. So what am I going to use? And by the way, other than all these 5 ways to buy Reserve, there's also the marketplace of reserved instances. Yeah, did anybody ever use the marketplace? Which is not a lot of people. And the reason is that it's just, you always need to monitor what's available in the marketplace. But when you find something good, it's very good. So it's like shorter term reserved instances and sometimes in a better price. So Eco combines all these type of purchase commitments and create a strategy. Just think about it as somebody that buys stocks from you from the public market. You're not going to buy only one stock and just put all of your money. You're going to buy a portfolio of stocks, and that's exactly what Eco does. So Eco is essentially giving you the maximum amount of savings and the maximum amount of flexibility and the maximum amount of time savings for your team, so you don't have to go and calculate what other reserved instances I need to buy, or we know there are a lot of other platforms that tell you, these are the reserve capacity you need to buy, good luck. So Eco is actively managing this, and I think that's why we're seeing that tremendous amount of demand for Eco. Eco is also available for MSPs and large enterprises, because we are also aware that sometimes in an organization, different business unit kind of work as different companies. Also in our company, this is how it works. We have Spot, we have the storage division, we have the monitoring division, different budgets, different types of people who buy cloud. So Eco can work also across multiple organizational units and basically providing this value of creating this phenomenal portfolio strategy and executing on it. By the way, Eco is free to get started in terms of discovery. So you can just spin up Eco, connect it to your account, discover what type of reserve capacity Eco recommends you to buy. Sometimes it even looks at your existing reserve capacity and existing savings plans and give you a recommendation on what to change. And that's even free of charge. And then based on the plan that Eco prepares, it executes on it, and you just sit down and count the savings. Are you still awake? Yeah? All right. Now switching gears to security. This is a recent thing. And just tell you a personal story. Before we got acquired, so we had this crazy idea to launch a security product. And the reason was that if you think about that, in the last 10 years, 99% of the hacks in the cloud happened because of misconfiguration and not because of sophisticated hackers. It's because people are deploying lots of services, and people are leaving holes, and people are not always, just because they work fast and they deploy a lot, so they forget things, and then other people just take advantage of it. They forget keys, they forget security groups, they forget policies, and they just don't do it. So we said, hey, people are already running resources through us, provisioning resources through us. It's inevitable that we will help them to find these misconfigurations. And this personal story goes to, then we got acquired, and then I presented my roadmap at NetApp, and people called me crazy. Like, hey, why would you want to get into that security space? And why would we do that? That's like a suicide. And right now, I think 18 months later, I think NetApp understands, and especially Spot by NetApp understand that not only that we need to be in security, we must be there. We must be there, and this is a growing portfolio. This is the first product that we're releasing out of multiple more modules that are going to come into Spot Security. So this is an area that you're going to see us investing a lot in the near and long future. So what do we have for security? I see it from NetApp, and that's also my personal perspective, and I see it in multiple other companies. The way that security works in 30 seconds is you have a CISO that buy tools, and then we have the guys that report to the CISO with the tools that they bought, generating reports, and then sending you an email of, hey, you're going to fix this by this date, and if you don't fix it by this date, in Hebrew we say, oy va'avoy, you must do it. And then the engineering managers are looking at the list, and hey, we don't have time for this, we need to release a new version, and we're not sure why this is so important, this is not really putting at a risk. And then there is back and forth between the security team and the DevOps team on why to fix it and what to fix. And Spot Security, I would basically say that we try to create a product of security for DevOps. So it's not security for the team that reporting to the CISO and find all these long list of incidents that nobody really knows if they need to be fixed now or yesterday, or maybe they can wait a month. It basically gives the DevOps a posture management of everything that was deployed into their cloud account, the relationship between them. So then, because the DevOps deploy that resource, so they understand the context. If I'll tell them, hey, this image, this compute instances in this cluster is doing X, and it's connected in a topology to these other 100 resources, the DevOps person can understand it much better than a line of something that is related to a compliance that was breached. So this is why we build Spot Security. And so Spot Security is basically mapping the resources topology in every given cloud account, putting it against best practices and against compliance and different SOC 2, for example, regulations, and telling DevOps if they're in a position that they need to change something, but not only to change it, but also create a remediation plan so that it will be baked into the way that they are deploying. So as you see here, I don't have the screenshot from the product. That's too bad. But the entire Spot Security is built on a risk map, which is a very cool graph database that we have behind the scenes that's showing all the connections between the resources that are affected when we identify a security risk. So whenever we see an image that is part of a CVE that someone needs to know about, so we can tie that image with that compute instances, with the pod that is running on it, with the storage that is attached to it, with the ENI that is attached to it, and the load balancer that is receiving traffic, and then the DevOps can have the full picture of what is affected, and if that's really putting my company at risk, it's something I need to do now. So it's really about bridging that gap between getting security tasks and executing on it to understanding really what I need to do. Still awake, right? Yeah, okay. Lots of content, I told you. Lots of content, lots of products. reInvent 4 years ago, we had much less products. I was just doing my talk was very only technical about one thing. It was much easier. But now, when I think it's fortunately when we present the company, it's a lot of moving pieces, and I think it's a blessing. It's a good thing. So, PC Ops. We recently launched a product we call Spot PC. So Spot PC is really, again, when we build products, we think, again, cloud is getting more complicated and more expensive. So, and we're seeing more and more people consuming desktops in the cloud. And we said, how can we take all of our all of our experience in managing Spot instances and find one more amazing workload type that can benefit customers. And we thought about desktops as a service. So now I'm very proud to announce that we're actually providing a fully managed desktop as a service that is using Spot instances behind the scenes with our technology of understanding when exactly machine would disappear, so we can move all the storage, all the network, all the sessions, and all the user data and context into a new machine. So you can basically have a virtual desktop as a service in the cloud at about 50% of the cost of any other platform that provides you desktop as a service. So let us conclude this. This is our mission of really helping customers to get their workloads on the right cloud infrastructure that they deserve and in the right availability type, scalability, and the lowest possible cost. This is how you can connect with us, and I'm happy to leave room for questions and comments. I hope you enjoy the session. All right, so have a great evening, everybody, and hope you and your loved one are well and safe. Take care.